My name is Allegra Missildine, and I am one of the solution specialists here at Altair. Before coming to Altair, I was a nuclear missile operations officer in the Air Force. I've been with the company for over 4 years now, and working in the aerospace vertical, assisting customers in finding solutions to their problems. So let's dive into the platform a little bit more. Altair RapidMiner is a true end-to-end frictionless AI platform that covers all analytical tasks from data ingestion, processing, modeling, and operations. It helps to support the collaboration between all data stakeholders and removing any friction between the different audiences. It accelerates users from concept to production by offering auto ML visual workflows and coding for all aspects of data science. It empowers users to extract and prep data easily from any source, and it can help you to modernize established data analytics environments such as SAS and Python. And with our desktop and cloud offerings, we cater to enterprise needs in a seamless, future-proof way. So today we're going to be going over some features within Altair AI Studio, formerly known as RapidMiner Studio. It is the data science tool anyone can use to design and prototype highly explainable AI and machine learning models that help build trust throughout your organization. Altair AI Studio offers a visual drag and drop workflow designer for non-coding domain experts, automated machine learning tools, support for generative AI, and interactive data prep capabilities. So today we're going to go over building and validating machine learning models in AI Studio. So one of the challenges that people can face is feature selection. So sometimes it can be difficult to know which variables in a data set are worth including and which ones could hurt results. It can also be hard to figure out which model is going to be the best for the problem you're trying to solve. And validating model results can also be a challenge because some people might not be sure if the model is actually giving them good results before inputting any new data into it. So by using AI Studio, you can use Auto Model to not only help filter out any irrelevant data, but also to help compare the results of different model types to find you the best one. You can also create a confusion matrix to help interpret the results of your model as well. All right, so we're going to go ahead and go into the demonstration. All right, so we're going to be working with some census data for this demonstration. So I'm going to go ahead and just bring that in and then connect retrieve census to the results port. And then we're going to run this by hitting the play button here at the top. So this is a demographic data set for an email marketing campaign. And each row corresponds with an individual that we sent this campaign to. And we're tracking whether or not they interacted with the campaign. So we're essentially using this information to determine what demographic is most likely to respond to our next email campaign, so we can be more efficient at targeting the proper audience to get the best response rate. So the first thing we're going to do is go up to Auto Model. Now, there's a couple of reasons why you want to use Auto Model. The first is that it's a great place to get started with building a data science model. The second is that it's good for feature selection and comparing the different models so we're able to choose the best one. So we're going to go ahead and select Predict from these three buttons at the top, and then we're going to go ahead and select the response column. Since we're tracking response as the target variable, that will be using our model to predict. We're going to hit next. This is mainly for renaming the classes or dealing with imbalanced classes, but we don't need to fix anything here. So we're going to hit next again. So this is where we can do some feature selection. And this uses a tiered system where it uses correlation to determine how strong these variables are. Down below each of these are columns in our data set, and they've been ranked from green to red. Red is, of course, going to be things that may not be useful to our model, like a customer ID, since it's random and unique. Then you have marital status, which is yellow. So it may not be the best, but you can use domain knowledge to decide if you want to keep it. For this demo, we will. So this is essentially how you would get the first look at selecting variables for a better model. We're going to hit next again. And here is another big value of auto model. It's tough to know which model will perform the best, so you can actually run the models against each other. For the sake of time, since this can run a little long if we have them all selected, we're just going to select a few of the models to run. But of course, a good practice would be to run more or all for the best results. So I'm just going to go ahead and deselect some of these. And then we're going to go ahead and hit run. So now that it's running all these models against each other, it'll start to give us the results of each. So we're just going to go ahead and wait for it to pop up. All right, our naive Bayes finished first, and you can see that it gives it a little award for stuff as well. So it has best performance, best gain, fastest scoring time, and fastest total time. So that'll just give you an idea of where each model stands essentially. So we can actually look at a few things while this finishes. So on the left, we can select performance for naive Bayes. And then we can look at the confusion matrix, which is the main way we can assess classification problems. So the confusion matrix is basically a scoreboard for evaluating how well a classification model is performing. And it helps us see where the model is getting this right or making mistakes, which will help us improve its accuracy. So for example, it predicted no response, and then was, and here's where it was an actual no, versus it predicting no and it being a true yes. And then same here, it predicted yes, but was actually a no, and then predicted yes, but it got 563 for a true yes. We can also go over to predictions. And then this will basically show you row by row each prediction, as well as some of the variables that have color coding that shows how impactful they were in that prediction, as well as the confidence threshold. So you can see that this column here has the predictions versus the actual response. So you can see even in row 3, it predicted no, but the actual response was yes. And then another thing we can look at is the weights. So we can come over here to the left and select weights. And then this basically shows the actual impact of each of these variables. So marital status, you can see, ended up being a very strong predictor on whether or not somebody would respond to the campaign. So now that we've given it some time to finish running, we can go to the overview here and then check to see which one performed the best. So as you can see, naive Bayes did. And then for logistic regression, it actually scored for fastest scoring time. So that's kind of how these little awards work. But if we wanted to, we could actually look at each of these models as well, just to kind of see. So if we want to generalize the linear model and clicked performance, we can look at the confusion matrix and just see that it did like slightly worse than naive Bayes in its predictions. And then same thing for logistic regression, just coming over to performance. And then same thing, just a little bit worse than naive Bayes. So naive Bayes performed the best out of all of our models. And so essentially this is going to be the first step in building the model by figuring out which model is going to perform best. And once you know that, you can build it in design. So this is definitely the first thing that you should do whenever you're trying to build out a model like this. And one more thing before we go, you can see here you're able to save as well as export your results. So you can use different components from the models as well. All right. So today we basically went over validating the machine learning models. So that's a precursor to actually building the model itself. If you have any questions, please feel free to reach out to me at Missildine@altair.com. And just a reminder that you can use the various DA tools in the data analytics suite with your existing Altair units. Thank you for joining me today during this coffee break. And I look forward to seeing y'all in the next one.